question number 1. The 2-meter rulers made of material of linear expansivity 5 into 10 to the power minus 6 per Celsius are calibrated at 0 degrees. One end of each of the meter ruler is fixed to a vertical ball and held side by side, horizontally as shown in the figure. One of the meter ruler is maintained at 0 degrees Celsius and the other 100 degrees Celsius. Which of the following two scales making of meter ruler coincide with each other? I will consider the linear expansion of the meter ruler. We can write delta L equals L1 alpha theta. And I will consider 1 millimeter initial length. 1 multiplied by linear expansivity. Alpha is 25 into 10 to the power minus 6. The temperature difference, temperature increment is 100 degrees. Then we can get 25 into 10 to the power minus 6 millimeters. It means the increasement of length 25 into 10 to the power minus 6 millimeters for initial length 1 millimeter. If the initial length is 1 millimeter, expansion to 25 into 10 to the power minus 4, not minus 6, it is minus 4. Then we can get we can obtain 1 millimeter linear expansion for 1 over 25 into 10 to the power minus 4 initial length. If the initial length is, if the linear expansion is this value, initial length should be 1 millimeter. Then if the initial expansion is this value, 1 millimeter, we can get initial length should be 1 over 25 into 10 to the power minus 4. Then I will simplify it. We can bring 10 to the power minus 4 to the numerator as 10,000. Divide by 25. 400. Therefore, if the initial length is 400 millimeters, we can obtain 1 millimeter increasement of length. Therefore, we can see that 400 millimeter part, it means 40 centimeter part of the expanded meter ruler is coinciding with 40.1 centimeter part of the non-expanded meter ruler. Then we can get fourth one is the correct answer. Then question number 2. A spiral spring of length capital L, number of 10 turns A and coil diameter D is heated from temperature theta 1 to theta 2. If the linear expansivity of the material of the spring is alpha, the increase in length of spring will be. We can consider this spring as a rod with initial length L. Therefore, we can use this equation. Linear expansion delta L equals L1 alpha theta. Directly we can consider spring as a rod. Therefore, length of the rod is L. Linear expansivity alpha, temperature difference theta 2 minus theta 1. Then we can get answer is 2. The graph shown in the shown the variation of length L with temperature theta of 4 metal strips A, B, C, D 5 bimetallic steps are made from pair of these metal strips, which bimetallic strip will be bent upwards when one end is stamped and heated. Bimetallic strip means there are two materials. There is a difference of linear expansivity. Therefore, it is bending when heated. Therefore, and they have given bend upward when one end is stamped and heated. This one is the stamped end. Then increasing temperature, it should bend upward. It means linear expansivity of this material, alpha 1, should be greater than alpha 2. We can compare linear expansivity by using gradient of given graph. This one is the correct answer. In this one, this material is B, this material is C, and expansivity of B is greater than expansivity of C because of gradient of graph B is greater than gradient of graph C. Therefore, we can get 5 is the correct answer. An aluminium plate 80 centimeters 80 millimeters 20 millimeters contains a rectangular hole with dimensions 20 millimeters into 5 millimeters. When the plate is heated uniformly, length increased by 0.002%. The length of the hole. We have to understand the hole is expanding same as the material. Therefore, we can get percentage increasement of the length. Delta L equals L1 alpha theta. Delta L over L equals alpha theta. This one is the fractional increasement of length. We can get percentage increasement of length by multiplying with 100. We have to multiply by 100. Then alpha theta multiplied by 100. This value, percentage increasement of length is given as 0.02002. Then we can find alpha value. They have not given temperature increasement. Then I will get alpha theta product. It should be equal to 0.002 divided by 100. Then I will use it to find the increasement of hole, increasement of length of hole. Then I will use delta L equals L1 alpha theta for the length of hole. Length of hole is 20 millimeters. I will use millimeters value. Then we can obtain answer in millimeters. Alpha theta product is this one, 0.002 divided by 100. Then we can simplify it. We can get 4 into 10 to the power minus 4 millimeters. Then increase in temperature, there is an increasement of length. Therefore, 4 into 10 to the power 4 minus 4 millimeters increasement. Answer is 1 for the figure A shows a circular hole of diameter D cut in a uniform aluminium sheet. Figure B shows a uniform circular aluminium disc of diameter D. Figure C shows a piece of uniform aluminium wire bent to form a spiral. if delta dA, delta dB, delta dC are corresponding changes in D of A, B and C respectively for a given temperature change, then we have to consider the relationship between delta A, delta dA, delta dB and delta dC. Then increasing temperature of all three items, we can consider diameter as a rod. Then we can get expansion of diameter. Considering expansion of diameter, in first one there is a hole, second one there is a paste, third one there is a spiral wire, but all three diameters are same. Therefore, initial diameter, we can consider that it is initial length of the all three items are same. Therefore, increasement delta dA should be equal to delta dB and delta dC. There is the same increasement of diameter. Then we can get fourth one is the correct answer. The fractional change of the volume of solid when heated from 0 to 10 degrees is 0.00727. The linear expansivity of the material of solid is. They have given fractional error of change of volume. Then we can get increasement of volume delta V equals V1 gamma theta. V1 is the initial volume, gamma is the volume expansivity and theta is the temperature increasement. Then we can get fractional change means increasement divided by initial volume, and we can get for a solid material volume expansivity is 3 times of linear expansivity. Then we can get gamma is equal to 3 alpha. Temperature difference is given as 10. Then I will substitute fractional increasement of volume 0.0027. We can bring 3 and 10 to the left hand side. 3 into 10 equals to alpha. Then we can cancel out 3 divided by 3, 1, 0.0009. When dividing it, we can obtain 0.00009 per Celsius or per Kelvin. We can use per Celsius or per Kelvin because of we are using 1 degree difference. 1 degree difference in Celsius scale is equal to the 1 degree difference of Kelvin scale. The answer should be 2. The volume expansivity of a metal is equal to, we know that it is 3 times of linear expansivity. Then answer is 3. The circular hole is made in a steel sheet of linear expansivity 1.2 into 10 to the power minus 5. When the temperature of the sheet is raised by 100 degrees, the area of the hole, we have to get the fractional change. Then I will use the area expansion equation. Delta A equals A1 beta theta. Fractional change of area delta A over A1 equals, they have given linear expansivity. We know that linear expansivity is 2 times of area expansivity is 2 times of linear expansivity, then 2 alpha theta. 2 times alpha value is 1.2 into 10 to the power minus 5. Temperature increasement 100 degrees. 2 into 1.2, 2.4 into 10 to the power minus 3. This one is the fractional increasement. When increasing temperature, there is an increasement of area. Then answer is 1. A coil of metal wire made of a material of linear expansivity 2 into 10 to the power minus 5 per Kelvin has entered when the temperature of the coil is increased by 1 Celsius degree while keeping the radius r constant. The number of turns become n plus 1. The value of n is, we can consider linear expansion delta L equals L1 alpha theta. Initially, there are n number of turns. Therefore, we can get, now we can't get this one as a rod because of they have given number of turns are increasing, but radius of spring is constant. Therefore, increasement of length should be equal to length of one loop. It means 2 pi r. The increasement of 2 pi r. Increasement of length is 2 pi r. We can get initial length 2 pi r times 10. There are n loops. Linear expansivity 2 into 10 to the power minus 5. 2 into 10 to the power minus 5. Temperature difference 1 degree Celsius. Then we have to find the n value. We can subject n value 1 over 2 into 10 to the power 5. 1 over 2 means half. 0.5 into 10 to the power 5. It means 5 into 10 to the power 4. Then answer is C. Consider the following statements made about the linear expansivity of a material. Statement A. The SI unit is Kelvin. Yes, it is correct. SI unit is per Kelvin. Then statement B. Its value changes when temperature is measured in Celsius instead of Kelvin. So we know that 1 Celsius difference equal to the 1 Kelvin difference. Therefore it is false. There is the same value when using Celsius and Kelvin. Part C. Its value changes when temperature is measured Fahrenheit instead of Kelvin. Yes, Fahrenheit, difference of 1 Fahrenheit degree is not equal to 1 Kelvin degree difference. Therefore, it is correct. Then A and C are correct. Answer is 2.